Hello again, this is Eric, a senior consultant at RNItechnology. In this video, we will iterate what was covered in the course, in short, regarding explosion-proof installations and protection against explosions. When it comes to hazardous locations, the installation is supposed to have several properties. One of them is the ability to purge the pressure out. So if we have under an explosion electrical energy that is exploding and expanding, somehow we're supposed to purge it out. That atmosphere is supposed to be distributed and leveled so the damage will not be that high to the equipment. What is known as explosion proof, where the equipment, cabinets, conduits, supposed to be holding against the explosion atmosphere getting into the device, into the cabinet. And intrinsic safety, that means to limit and prevent the electrical energy from building up. When it is building up more and more and more, any ignition will turn it into explosion. When it comes to purging the atmosphere, each and every stretch of the installation and the circuit supposed to include a purging point. In this joint, coupling joint, for a conduit, as you can see, there is a special nozzle. That nozzle is supposed to allow pressures to purge out. In that equipment panel, that equipment box will include purging points. Purging points. In the same time, an explosion happening here should not travel down or up into the conduit. So special coupling supposed to be installed before and after that will hold the explosion back and will not allow it to cascade on and on and on. If we don't do and use all those given measures, what we can expect is disasters like that, where the entire factory was destroyed. There are two directives under the standard known as ATEX, which is a European standard. It has two parts, 1 and 2. The 1999-92, which applies to atmospheres and the potential explosion in the atmosphere. And the other one is the ATEX 92-9, which applies to equipment and its withstanding to explosion. One of the main thing and foremost is the division into different zones of risk. So the standard, when it comes to atmosphere, is specifying which one is which. For an example, zone 1 is a very high risk gas and vapor. Zone 2 is a medium risk. Again, gas and vapor. Zone 21 is a high risk for powder and dust atmosphere. And zone 22 is a medium risk. Now we have equipment on the market. That equipment, before we purchase, we have to know that it is a zone 1, zone 2, 21 or 22. So it will fit our installation, our environment, and our atmosphere. That must be done in order to cope first with the standard, second with insurance issues, and third for the safety of the public and equipment. How do we know what is specified and what is equipped for with the ability to cope with different environments? This is the marking. And each and every explosion-proof equipment is supposed to come with the EX symbol. And there are several letters that will define the equipment group, its category, if it is for gas and dust or other specifications, its explosion protection ability, the protection type, the explosion group, and so on and so forth. When it comes to the temperature, which is part of the designation, of the marking, there are about 6 different temperatures to apply. Like T1, which is up to 450 degrees Celsius, and T6, which is up to 85 degrees Celsius. Each one of them is different. We're supposed to fit the equipment, which is marked with a temperature, to the environment that we have. We're supposed to fit it. If it doesn't fit, we don't have a proper explosion protection. If we have a higher grade equipment to a lower risk, when it comes to the point of view of protection and safety, that is fine. It's a waste of money, but it is fine, safety-wise. The other way around is not good, is unacceptable. And there are several things that we can do in order to fit the risk and equipment. Like raising the flash points or lowering the processing temperature in order to prevent the fault from happening, the explosion from happening. Including ventilation, and so on and so forth. This subject and its specifications are going very far with many details. For an example, we can see that if we have a tank being filled from a truck, each part is different when it comes to explosion rating. The tank itself is zone 0, which is a high risk. That tank on the truck is zone 0, high risk. But the environment around it is only zone 1, which is not that high of a risk. Meaning the risk is there, but it's not that high. The equipment installed here must be different than the equipment installed here and here. When we go beyond that range of the truck and the tank and the immediate vicinity, we go into zone 2. Zone 2 is a medium risk. And the equipment installed there is supposed to be different. Another example is a flammable liquid being stored in a location, storage location, and we can see that this is zone 2, zone 0, zone 1, and zone 2, meaning extreme danger, high danger, medium danger. By looking at the numbers 0, 1, and 2, we can see right away that we are talking about vapors and gases, and not dust. The equipment that we purchase in order to install in that environment is supposed to be adequate to zone 0 level, zone 1, and zone 2. Another example, when we have a sack emptying station, we can see right away where there is a concentration of dust. It is a high risk. Around it, it's a lower risk. And around that is a medium risk. We can see that the zone is 20, 21, and 22. Immediately we understand that it is dealing with particles and dust, as opposed to gases and vapors. Another storage area for some liquid, flammable liquid, we can see right away that we are talking about gases, and we have to define the immediate danger. And the distance is known, like 3 feet around it, and 15 feet around it, and the total area. Each one of them has a different risk. Well, the red area is known as Class 1, Division 1, or Class 2, Division 1. It defines a certain risk. Well, that area is a lesser risk, so it will be a Class 1, Division 1, or Class 2, Division 2. Class 1, Division 2, or Class 2, Division 2. The danger, the risk is lower. The type of equipment we put is different. When we have a chance for or a risk for explosion, usually we have fuel there, oxygen, dispersion, ignition, and contamination. All of those will lead to a hazardous area, to an explosion. Part of the specification is the gap when we close equipment. How big is that gap? How big is that gap? How big is that gap here? Even in the thread closing an enclosure, that is being taken into account as well. And it will be different groups, depends on the gap. For an example, if the gap is 0.9 and above, it will be group 2A. If it is lesser, group 2B. If it is lesser than 0.5, group 2C. Each enclosure as such, when it comes to equipment, has a NEMA standard. NEMA is a standard specifying body. And NEMA says this enclosure is a NEMA 7. NEMA 7 is for Class 1, Group A, B, C, or D. Well, NEMA 10 is different. NEMA 9, for an example, is for Class 2, Group E, F, and G. We're supposed to fit the NEMA enclosure type to the situation. For an example, on lighting fixtures, we're supposed to allow heating to go up and down. Right beside it, we're supposed to have a purging point. We're supposed to have a special coupling. So an explosion here will not continue and cascade beyond that fixture. Very important. The same goes here. For explosion-proof installation, we're supposed to have special equipment. Much stronger to withstand explosions. In all those examples for installations, we're supposed to have right after and right before each and every piece of equipment that type of a coupling, where an explosion will be stopped right here. It cannot continue through the coupling. That type of equipment, enclosure, for hazardous location, it's supposed to have rigid conduit, even if it is for only lighting. The lighting fixture is supposed to be adequate for explosions. The switch supposed to be as such. The installation is supposed to be rigid, and we're supposed to have special couplings for purging the energy. Electrical equipment will be marked like that. And that depends on the standard that is defining them. The standard in North America is different from Europe. Most of the world will adjust itself to those two standards, the North American and the European one. There is a difference between the two standards. When you purchase equipment, you're supposed to agree with your purchasing department and the special department or authority in your location that inspects your system, that they agree with the European one or North American standard. Which one is going for you in your location? Very important. In this diagram, we see that there are different installations for gas and dust. And even when this computer system is going to manufacturing, is going through the wall, when it is going through a wall from office environment to manufacturing environment, it will change rating. Like here we have an extreme danger and hazard for explosion. When you pass that wall, it is going down, it's dropping to 1, hazardous area 1. And when it goes to the office environment, it's going into a 2 grading. So grade 2 is different. It's a medium. This is a high risk, and this is an extreme risk. Here we might see sensors and other equipment which is on the manufacturing site, exposed to flammable liquids. Well, here we have the PLCs and the monitors, but not in the direct connection to the liquids. Therefore, it will be in a less hazard and risk. In the office environment, we have computers, we have controllers, but they are away from the risk. Still, the entire environment is risky, so it will be considered as risk medium. And all those zones of danger are setting, which equipment can we install. If we don't install the right equipment, we have a high risk of a misfit. The inspection will not pass the equipment and our installation, and the insurance, in case of a fault and a damage, will not cover this case. That is why we have to know what are the rating and setting for our environment and equipment. And that will summarize the very basics and fundamentals of explosion-proof installation. Thank you.